All right, so we're going to now look at experiment 6. And experiment 6 is kind of a fun experiment because we're going to set up different stations. We're going to have different stations, and at each station you're going to have a different chemical reaction. Okay, that's going to take place. And if you look at your report sheet, so like for example, reaction 1. In reaction 1, we're going to take some copper, and we're going to react it with some nitric acid, HNO3, nitric acid. Okay? And the products of that reaction are going to be copper nitrate, water, and most of the reactions that you have, there's going to be a blank. So it's going, in this case, the blank would have been NO2. They filled it in for you. Okay? So as you're going through these simple chemical reactions, you're going to be predicting the product of those reactions. You can see where you're going to be doing that, right? And then you are going to balance the reaction. You're going to balance that reaction, and we're going to talk about balancing, how to do that. Okay? So in that way, it's kind of a fun reaction, a bunch of different little reactions that you go around, you characterize, and you determine their products. And some of them are pretty fun. All right. So when we're talking about types of chemical reaction and we're trying to describe a chemical reaction, you can see here as you go through this, there's going to be, in part A here, describing chemical reactions. You're going to have different ways that you can identify whether a reaction is taking place or not. Okay? So if a gas is being produced, then that's a good indication that a reaction is occurring, taking place, happening. Okay? How will you notice a gas? So you had that happen today, actually, when you reacted the magnesium with the hydrochloric acid. Began to bubble. A gas was being produced. So when you get bubbling, that is an indication that a gas is being released. Okay? And if it's in solution and bubbles are formed, those bubbles are escaping. You can see the bubbles coming out of solution. Right? Okay? So looking for bubbles. Bubbles would indicate that that product is a gas. Okay? We can classify our chemical reactions in these ways: combination, decomposition, single replacement, exchange, or I'm going to also add double replacement. Okay? So, a combination reaction, as you can see there, it's very straightforward. A plus B will form AB, right? That's very straightforward. You put them together, you have combined those things together, and they have formed that new product AB. Okay? It was A and it was B, but then you put them together to form AB. So, for example, H2 plus O2 produces H2O. Okay? So it's a combination of those, putting them together. Decomposition would be the exact opposite of combination. Combination is putting them together, while decomposition is splitting them apart. So starting with water, you would decompose it into H2 plus O2. Okay? So you can see AB is decomposing into A plus B, back to its original components. Okay? A single replacement reaction is a reaction where you take A, which is usually, not 100% of the time, but a lot of percent of the time, a metal. Okay? So you have a cation. Well, it's not a cation when it's by itself because it's just the solid metal, so it's not cationic yet. But you take a metal and you take an ionic compound, Bc. So you have a positively charged B and a negatively charged C. Okay? And A has a greater, let's see. I should say B has a greater affinity for electrons than A. So B picks up A's electrons, and then B bounces out and gets displaced by A. And then now A is positively charged, so it's the cation, so it's going to combine with the anion C. Okay? So you have displaced one of those. That's a single displacement reaction. Single displacement reaction. Okay? So B plus AC is the product of that. Let me think. A good example. I'm trying to not use the one that's in the. Okay. If you have something like copper plus zinc nitrate, okay, then you would form zinc plus copper nitrate. Okay, that would be a single displacement reaction. Single displacement. Think about that. Okay, now with a double replacement or an exchange reaction, what is happening is you have two ionic compounds, AB plus CD. And the cations here are A and C. So those are the positively charged things. B and D are negatively charged. Okay? And what happens is that the positive cations switch partners. They just switch places, and you end up with the cation A now with the anion D rather than the anion B. And the cation C is now with the anion B. So they just switched places. That is called a double replacement reaction. Okay? So, let's see. Lead. Let's take potassium chloride plus silver nitrate. Okay? So potassium chloride plus silver nitrate. And here I have K plus, Ag plus, Cl minus, and NO3 minus. Okay, those are my cations and anions. Okay, and they are going to change places. So I'm going to get KNO3, potassium nitrate, plus silver chloride. Okay? So when they change places, that's what they're going to do. That's what they're going to form. So we would say that that is a double displacement or double replacement reaction or an exchange reaction. So based off of these criteria, okay, in your report sheet, if you look at your report sheet, you would notice that it is asking you to classify the type of reaction. So like in reaction 2, you have copper plus silver nitrate, and then you'll get products from that. And it's saying what type of reaction would that be, and you would classify that reaction based off of these. Yes, ma'am?
So at the end where it says potassium nitrate plus Ag, right?
AgCl? Okay. Okay, so that's how we would classify those reactions based off of what's happening in the chemical reaction as we see it on paper. Okay? All right. So just in review, if you're writing a formula, okay, so here I have Al3 plus and Cl minus. Okay. Okay. Let's go back here. So Al3 plus and Cl minus. So to write the formula, I just take the charge from the other ion and I use that as my subscript in the formula for the other thing. Okay, so -1 charge here, so I need 1 Al, plus 3 charge here, so I need 3 Cls. So AlCO3. Okay, that's how I would combine those. Okay, to determine what product they are. If it's Al3 plus and O2 minus, then I would combine them by saying 3 plus means I need 3 oxygens. 2 minus means I need 2 Als. So Al2O3. Okay? So that's how you're going to determine those formulas. Okay. So really good idea to prepare for this lab. Look at all the different types of reactions that you're going to be performing. So reaction 1, you're going to be doing that. I'm actually going to do it. I'm going to do it under the hood. Okay, I'm going to have it set up under the hood, and when you come around, you can observe it under the hood. Okay, because it's going to be producing a toxic gas, so we can't have it out here in the room. We're going to have it under the hood. Reaction 2, you're going to take some copper metal. You're going to put it into a 15 centimeter test tube. Hopefully these are things that you guys are starting to become familiar with. Okay, you get a test tube, and I'll have stuff set up at the stations. You're going to have your test tube. You're going to put the copper in it, and then you're going to add 2 milliliters of the silver nitrate. So it's solid copper. You're adding silver nitrate to it. You're going to make some observations. That reaction doesn't happen super fast. I mean, it starts happening pretty fast, but you got to give it a minute. Okay, to make before you make your observation, you got to give it a minute or so, and you will start to see the change that's occurring. Reaction 3, you're going to take some zinc. So we have this mossy zinc. You're going to put it into a test tube. You're going to add some acid to it. Okay, it's going to react, and it's going to produce some products. And you're going to hold your thumb over the mouth of the test tube, and as the product is building up in there, you'll then put it close to a flame, and it will react a second time. So you're going to get a secondary reaction from that, okay, which is kind of fun. Okay, reaction 4, you're going to ignite a small strip of magnesium ribbon. Okay, everybody always seems to like to do that. Okay, the magnesium is going to be very bright, so bright that I caution you not to look at it. You'll be able to see it if you hold it to the side, okay? Because if you look at it, like you will, because I just told you not to, so you're going to, okay? Then you're going to be like, whoa, I can't see for a few minutes. Okay, you're going to be like, wow. Okay, so I caution you. I'm telling you, don't look at it. You don't need to. It's gonna be exciting enough if you look at it to the side. Okay, but if you look straight at it, it's going to bother your eyes. Okay, number 5. I'm actually going to do that reaction. I will demonstrate it to the class, and then you will finish filling everything out from the demonstration. Okay. Reaction 6. Going to take some copper sulfate, which will be a solution that is blue. Copper ions, copper 2 plus ions, are blue. So you're going to have this blue solution. It's clear, but it's blue. And you're going to add some ammonia to it, NH3 ammonia. Okay. Then reaction 7 is a follow-up of that. So you're going to do 6 and 7 at the same station. You're going to do 6. You're going to add the ammonia. You're going to make an observation. Then you're going to add you're going to add 10 more drops of the ammonia and make another observation. Okay? All right. Then in reaction 8, you're going to place 2 milliliters, 40 drops of some lead nitrate. Okay? And about the same amount, equal amounts of potassium iodide, Ki. Okay? You're going to see what type. This is going to give you a precipitate, and you'll be able to describe that. Okay? Reaction 9, we're not going to do. Don't worry about that one. Okay? And then reaction 10, I change up a bunch, and I'll explain it that day what to do. But you're going to take some. This is the famous vinegar and baking soda reaction. But they change it to be a fire extinguisher because it produces a gas that extinguishes fire. Okay, so we have some ways of having that work. Okay, so I'm gonna change it up a little bit. We'll talk about that one the day of. But those are the reactions that you're going to be performing on Monday. Okay, this coming Monday here in the lab. Okay.